So one last little quick situation when we're going to infinity that can be useful. Sometimes we can't cancel like that, so we have something called the squeeze theorem, all right? And the squeeze theorem says this: if f of x is between two theorems, okay, so it's between, meaning one or two functions, sorry. So f of x is between two functions, one's bigger, one's smaller. Then, and those two functions have the same limits, then f of x will go to the same place as they do, all right? More formally, we say this: if f of x is between p of x and q of x, so it's always between no matter what, and p of x goes to L and q of x goes to L, then f of x is also going to go to L, all right? So let's think about that. Here's an interesting one here, okay? So we have the limit of 1 over x over times sine x. Well, yeah, you can write this as sine x over x as x goes to infinity. Well, we can't use any of our methods we just did because we got, if you simplify this to sine x over x, well, what we just talked about doesn't really matter. These are both going, well, what is sine x going to? Sine x is always between 1 and negative 1, right? Because remember, sine, if you remember the graph, goes up and down like that. Okay, so it's always between 1 and negative 1. It's bouncing. And 1 over x, well, we know what that goes to 0 as we go to infinity. So here's what we can say. We know that sine x is always between 1, positive 1, and negative 1. Okay? The biggest that sine can be is positive 1. The smallest it can be is negative 1. All right. Well, that means this. That means that when sine x is 1, that's the biggest this can be. Okay? So then our expression becomes the limit as x goes to infinity of 1 over x times 1, which is obviously just 1 over x. And we know that this is less than the limit as x goes to infinity of 1 over x times negative 1, or negative 1 over x. Okay? So rewritten a little bit here, we can say this. The limit that we're looking for is in between the limit as x goes to infinity of 1 over x and the limit as x goes to infinity of negative 1 over x. All right, well, let's think about the graph here. So if we graph this, we have this, let's say this one right here, okay? Negative 1 over x. Actually, let's graph this one first. Let's graph y equals 1 over x. Y equals 1 over x. We're familiar with what that looks like, hopefully. It's going to 0 as x goes to infinity from the top. Okay, and this negative 1 over x, well, that's just going to flip this around. And so that's going to 0 as well from the bottom. Okay, well, what's happening with this red function here, the 1 over x sine x? First of all, let me write this. Y equals negative 1 over x. And so y equals 1 over x sine x. Well, that's going to go something like this. It's going to bounce in between these two. It's always smaller than the yellow one and larger than the green one. And eventually, it just squiggles on down to 0. Okay? So the squeeze theorem says this: as this goes to 0, and as the top one goes to 0, then we know the limit as x goes to infinity of 1 over x sine x is always greater than or equal to 0 and less than or equal to 0. So obviously this can only happen when it's equal to 0, right? You can't be greater than something or less and less than at the same time, but you can be equal. So this, by the squeeze theorem, is saying that x, as x goes to infinity, of 1 over x sine x, that equals 0. So we found the limit, and we proved it using the squeeze theorem. Okay? by the squeeze theorem. Because we squeezed it together, we showed, we proved to ourselves and the reader that it's always greater than one function and less than another function, and they both go to the same value, which is 0 in this case. And that's the squeeze theorem. All right. Well, let's end with one more interesting little application here, kind of weaved in between there. Okay, that was going to infinity. Now, this is going to, here's one going to 0. So think about this for just a second, all right? We know that the sine of theta is less than theta, which is less than or equal to tangent. Graphically, here's what that means. The sine of theta is this height right there. That's sine of theta. And theta in radian measure is the arc here. So the arc's a little bit more than the sine of theta. Tangent, probably haven't seen this much, but tangent is actually this vertical line right here that is tangent to the circle. And the value of tangent is, if we continue this line through the point on the unit circle made by the angle, then this value, this height right here, is the tangent of theta. So graphically, that's why the tangent is always is bigger than theta, which is always bigger than sine theta. Okay, so think about this here. If we take this and before sine is 0, so let's say as theta is going to 0, but it is not equal to 0. But if we divide all the way across by sine theta, okay, divide by sine theta, we get sine theta over theta, which is 1. We get theta over sine theta. And here, well, this is sine over cosine. That's what tangent is, right? Divided by sine. And we can clean that up by multiplying by the reciprocal. 1 over sine. These go away. Sine goes away. And this is 1 over cosine. Okay? 1 over cosine. See that? So this is 1 over cosine theta. All right. Well, since graphically we proved that this thing that's printed in black here, all right, we can divide by sine. Now this is when sine does not equal 0, because once it's 0, this doesn't mean anything. Okay, so sine theta is going to 0 because theta is going to 0. So as we can say this, all right, as theta is going to 0, what's happening to both of these expressions? So the limit as theta goes to 0 of theta over sine theta, well, it's got to be greater than 1 because it's always greater than 1. And as theta goes to 0, what is cosine of theta? Well, cosine of theta becomes cosine of 0, and cosine of 0 is 1. So this is 1 over 1, which is 1. Okay? So as theta goes to 0, we see the limit of theta over sine theta is bigger than 1 and less than 1, or equal to. And so obviously, by the squeeze theorem, we can say that the limit as theta goes to 0 of theta over sine theta is 1. And that's a special limit that we've seen. It's the reciprocal of the one that we saw. But theta over sine theta is also going to 1. So that's the squeeze theorem. All right, great job. And thank you for thinking through that with me.